Okay, this is our final video for section 5.1, and in this video we're going to work through some applications of differentiation problems involving natural log of x. Okay, so here in our notes, example number 11, we have x squared minus 3 times the natural log of y plus y squared is equal to 25, and we want to find y prime by using implicit differentiation. Okay, so just like all of our implicit differentiation problems, we'll go ahead and take our derivative term by term. So x squared, derivative of x squared is 2x minus 3 times, we need the derivative of natural log of y, so that's going to be y prime over y, or dy dx over y, plus 2y times the derivative of y. And that's all going to be equal to the derivative of 25, which is 0. Okay, so now we just need to go through and do some simplifying and then solve for y prime. So the next thing I'm going to do is I'm going to go ahead and clear out this fraction here with the y in the denominator by multiplying everything through by a y. So that gives me 2xy minus 3y prime plus 2y squared y prime is equal to 0. Okay, now anything that does not have a y prime in it, we want to move that over to the right hand side. So on the left hand side we're left with negative 3y prime plus 2y squared y prime, and that's going to be equal to negative 2xy. And now we'll go ahead and factor out the y prime. So on the left hand side we have y prime is equal to, I'm going to flip these terms around, 2y squared minus 3, and then on the right hand side we still have negative 2y, or negative 2xy. And now solving for y prime, by dividing we have y prime is equal to negative 2xy, and that's all over 2y squared minus 3. Okay, so just like every other implicit problem that we've done, the only thing that you're going to have to now know how to do in addition to the previous types of problems is knowing how to find the derivative of natural log of x and natural log of y. Okay, so now for our next application problem, we're going to find relative extrema. So here we have a function of y equals natural log of x squared minus 4x plus 6. And if we want to find relative extrema, remember we want to find out where the first derivative will change signs. So first thing we'll have to do is go ahead and find the first derivative. So y prime, we need the derivative of this natural log function, so we take the derivative of the inside, which was 2x plus 4, and that's all over the original, x squared plus 4x plus 6. And we want to set this equal to 0, or we need to know where it's undefined. Okay, so whenever you have a function that's a rational function, basically remember all you have to do is take the numerator and set it equal to 0, and then take the denominator and set it equal to 0. Okay, so doing that we get 2x plus 4 equal to 0, and then our other critical numbers will come from x squared plus 4x plus 6 equal to 0. Okay, so over here, solving for x, we get that x is equal to negative 2. And over here we have a quadratic, so first thing we can do is see if this quadratic will factor, which it won't. There are no factors of 6 whose sum is 2, so then that means we'll have to use the quadratic formula. Okay, but remember, in order to use the quadratic formula, we want whatever's inside of that square root. We want b squared minus 4ac. Remember, we want that to be positive. Greater than or equal to 0. Otherwise, there will be no real solutions. So when we check this, we've got 4 squared minus 4 times 1 times 6. And that's a negative number. So this is not true. So that means that there are no real solutions here. Okay, so that tells us that our only critical number to test is this one, x equals -2. Okay, so now we test by making a sign chart. So we're testing our derivative around the value for when x is equal to -2. So if we plug in a number smaller than -2 into our derivative function, for example, like -1 up into our derivative, we're going to get a negative number. And if we plug in numbers bigger than 2, or -2, so for example 0 up into our derivative function, we get a positive number. So that tells us that when x is equal to -2, we do have a relative min. So we have a relative min when x is equal to -2. And when x is equal to -2, we plug that back in to the original function up here. So we want to evaluate this y at 2. And you can just leave this in exact form. So if you plug in -2 and for x into this, then we end up getting just a 2. So that equals natural log of 2. Okay, so our relative min will be at -2, comma, natural log of 2. Okay, and now for our third example. So same typical problem we've been doing all year long, just now with a new type of function. We want the equation of a tangent line, and we have another function involving a natural log. Okay, so equation of a tangent line, remember the things that we need to find are the slope at the particular point that they give us, and we need a point. Okay, so we have the point, they give us the 0.14, so now we just need to know what is the slope. So remember, slope is just the derivative, and we want to know that when x is equal to 1. Okay, so first thing we got to do is go ahead and take a derivative. So y prime is going to equal 8x minus the derivative for natural log of x is just 1 over x. And now we want to evaluate this for when x is equal to 1. So y prime at 1. And when we plug that in, we end up getting 7. Okay, so now for our equation of our tangent line, just using point slope form, we get y minus our y coordinate, which is 4, equals our slope that we just found, that was 7, times x minus the x coordinate, which was 1. And then from there you can just convert it into whichever form you are asked to give in your final answer. Okay, so that wraps up our examples that we have for section 5.1. In your notes you do have 3 additional extra practice problems, so go ahead and take a look at those and make sure that you do get the answers that I have given to you in the notes, and if you do not get them correct, bring those to class with you so that we can go through this together in class. Okay, and we'll see you next video.